Namaste. So today I want to talk about a view of the space of AI that I had sketched some time back. It give by no means should this be called a complete or covers every aspect in all the detail, which I think is possibly not possible in with that level of detail. But you get an idea about what the scope of AI need to be. If you are looking at it, the field was AI, what are the kind of buzzwords that is going around, what kind of topics are going to be relevant. So let's take a closer look. So we were talking about search techniques in the earlier video. Okay, I haven't yet covered different search techniques, but we introduced the notion of AI as uh, AI as a problem solving, where the approach is to view the solution space as a search space. Okay, so we had different states. Some would be the initial state that you start from, some are goal states, some are the in between states that are reachable through various moves. So we had all that. And we were talking about how do we, from the initial state, how do we transition to a state that satisfies the goal properties through efficient ways. So one of the element was to look at search techniques. Here also there are a lot of things I have omitted. The A-star algorithm and all that are things which are relevant here. But also relevant are things like game playing, and colony optimization, nature-inspired algorithms, genetic algorithms. Some of these we will come and look at in course of time. And I was briefly touched on to the notion that we would need a lot of domain knowledge in order to efficiently do this problem solving in the AI context. Okay, so there is a lot of work that was done in the area of knowledge representation in terms of what are the different ways in which knowledge can be captured. So you will immediately recognize some things like rules. If then rules is something that we are all familiar with, and a lot of information we do communicate. If you cross a red signal, it is illegal, or if you are walking on the road, you should keep to the left side, and so on. Okay, so if then rules is a very commonly used way of knowledge representation. Logic is more formal. We'll again all of these we will talk about in course of time. So there were different ways to capture the knowledge: frames, rules, logic, networks, and all that. And there was also different aspects of knowledge like space, time, monotonicity, and all that, and associated developments that has happened. So this blob is basically kind of covering those aspects of knowledge. Okay, so again in subsequent videos we'll talk about all that, and that sort of brings in some contrast of symbolic AI versus statistical AI. So I generally say that the old AI is largely symbolic, and the current AI is mostly statistical. So again, we'll try to bring out those differences and all that in course of time. There were a couple of applications which used to be very popular, that was diagnostic systems and recommender systems, which also kind of characterized. Intelligent agents came as a way to organize AI systems as an agent. So you can anyways think of these as the traditional programming. You had procedures, then you talked about objects and classes, and then you had services. So somewhere along that line of abstraction is where agents and therefore intelligent agents comes in. So it is not really a core AI topic, I would think, but it's a way of organizing things to keep things under control. And there are a lot of applications that would be traditionally part of any AI course. So you have robotics, planning, vision, pattern recognition, speech. These are all common topics that you would find in an EIA textbook. And in under speech, you have recognition and synthesis. And on pattern recognition itself, I mean, somewhere along it overlaps with vision. And today we are also interested in video analytics, image recognition, image matching, and things like that. And planning, and is an area that you hear very little about today, partly because the new AI is really not able to deal with the planning problems or scheduling problems. Okay, and so possibly, and this is what Subbarao Gambapati in one of his talks says, that the deep learning models cannot handle planning scheduling problems. Maybe he will be proved correct. Maybe he will the deep learning technology will improve, that this will also be possible to cover. So, and machine learning came in as somewhere to address the knowledge representation problem, acquiring the knowledge that is required in some sense automatically or semi-automatically by the machine, and that itself became a huge area. And of course, inductive learning, semi-supervised learning, all these supervised learning, all these were the traditional parts of machine learning. And unsupervised learning, particularly clustering, also was a part of that traditional repertoire. Under the supervised learning, we used to talk about deep learning in an early stage, and now this has become a huge area by itself with the generative networks, adversarial network, transformers, and all that kind of stuff. Okay, so this is the space of machine learning, and as I said, today's AI is mostly has become a sub field of machine learning, kind of ignoring all other aspects, and that is something that we are not very comfortable with. So we would like to keep the focus broader. And one of the challenges that AI has always had was how do you deal with practical aspects of human reasoning. Okay, human reasoning is tradition. I mean, is the characteristic is that we are able to deal with uncertainty, incompleteness, dynamic world, whereas most of the system that we build assumes a given world and then you try to reason with it. So as you reason with it, the world outside is changing, so dynamicity is important. Uncertainty is very important because very little things that we know for sure, and we don't have complete information, everything. So uncertainty itself became a big topic, and a lot of work was done in that area. So fuzzy logic, Bayesian models, Bayesian networks, these are some of the prominent ones under this umbrella. And there are others also, like certainty factors, which also we will talk about at when you talk about that topic. Natural language processing, in a way, that should be placed along with the vision planning as an application, but then it has also emerged with a lot of sub problems, partly because understanding and being able to generate text is kind of considered as a key element of intelligence, so that got extra attention because of that. And we also realized that text translation from a language to a language or understanding text became an extremely difficult problem as the researchers found out in course of time. So NLP became a fairly big area by itself: information retrieval, sentiment analysis, discourse analysis, machine translation, and of course currently the large language models also a kind of field of sub aspect of NLP. And for ChatGPT, BERT, and a whole lot of other things are other instances of LLM. And today we are also talking about SLM, for example. So if you look at, when you talk about AI, somewhere you should actually keep this whole perspective in mind. Okay, and that's what we will also be doing as we go along. Okay, and so that is it for today. And I will continue the thread in the next video onwards.